Okay, now with respect to time history analysis, okay, so here what you need to do is first you delete the load cases of response spectra which we have created. Okay, so now what I will do is I will just define the function in the time history. Okay, so here see these are all the standard ones, sine, cosine, ram, sawtooth. Okay, so if you want to have some specific, so you have to go to the user. Okay, so add new function. So user from file. Okay, this option from file add new function. So you have to browse. So in that what I will do is I will go to my pen drive. Okay, so this one. Okay, earthquake data. So these are the El Centro 180, 270 earthquake which has happened, right? So I will just click on to this. Okay, so I will again open that file. Okay, so which I need to 270. Okay, so here you see what it will do is it has given the see peer NGA is a website where you will get all the data. Okay, so it is of Imperial Valley. It is happened in 5/19/40. Okay, so El Centro and all the values are in the units of G. Okay, so that's why so number total 4,000 are there. Okay, and 4,000 values these are given. Okay, earthquake data of acceleration with respect to time, and time is per 0.01 second, it has been noted. Okay, and all the units are already in terms of G. Okay, so when what you have to do is you have to take this here, you already added. So what is trying to first is like what is the interval? It is 0.01 second. Okay, so that because here in the file he has told you 0.01 second. Okay, so total number of steps are 4,000. So here, uh, so next header lines to skip. What is the meaning of that is like how many lines I should skip, because the values are starting from here. Okay, it is not starting from here. So first 4 lines it has to skip. So what I am going to define is 4 lines you skip. Okay, prefix charge per line to skip. What is the meaning of that is, see here sometimes it will be given some G or some values here and there prefix. That if you want to remove that prefix or suffix what it is, so then you have to use that. Right now it's a simple value. There is nothing at all involved in that. So that directly let it be 0. So number of points per line. See now this is first line, this is second line, this is third line, this is fourth line, this is fifth line. So it what number of points per line is total 5. So I have to define here as 5. Okay. So now interval is 0.01 seconds. Okay. So that's why I have given as 0.01 second. So this is how when you properly define this, your acceleration with respect to time history curves will come here. So next is okay. So it will read from here. Okay. So next after that what you have to do is go to the load cases. Here add new case. Okay, so here time. So it is a time history. Okay, so linear time history. So mass source. So here add. So here again acceleration. So that is U1. So it is El Centro 270. Okay, scale factor is here 9.81. Okay, so because already the values are in terms of G. Here it is written the inputs are in terms of G. So okay, so then model transit. So here number of output files actually it is 4,000, right? So and output time seconds is 0.01 second actually. Okay, but if you want to give it as 0.1 second, it is okay. So this is what is there. Okay, so then once it is defined, so you can ask it to analyze. So it will take little bit more time. Okay, so then what? Display story response plots. Okay, so here what you can do is, here you can ask time history, in that maximum story displacement. So here time, maximum and minimum. So this is a minimum and maximum story displacement it will give you. Okay, because it is reading the values like this. Okay, like this one. Okay, so that's why. So plot function, combined response plot, this is most important. See, this is your drift, this is your displacement, this is shear, and this is outer. So with respect to this earthquake, what L center of ground motion 270, the building behavior is this one. This is displacement, drift, shear, and overturn. So what you can do is, you can just ask that time. Okay, you can just ask the time. Okay, so load step 1 2 3, it will keep on happening. Okay, so you can see this red one, right? It is, as wherever it is going, the reading is showing here. Okay, so it will tell you exactly. So you can see that the behavior of the building is how it is changing, right? So this is how the building is deforming, and it's varying displacement, drifts, and shear. Okay, so you can just ask it to do faster, animate. See, it is animating by itself. Okay, along this earthquake data, it will read and give you the results. Okay, so this is what you can do. Okay, then design also display story data tables. So here also you can just see that. Okay, this is how you need to do this one. So here you can ask time. So here it is absolute max. You can ask that. So this is an absolute max value. It is showing you. Okay, so absolute max means at some seconds. Okay, what is the deformation? Absolute max means, I told you, that is the maximum response of the displacement, maybe positive or negative. Okay, so then this is a moment, absolute maximum. So this is with respect to maximum moment 3. Okay, so this is the shear, what you can see. So this is how you need to do that, and you can generate the report also. Okay.